Hello, welcome everyone. Today we are starting vectors. Vectors is one of the most important topic of GCSE mathematics because generally you will find these questions in 5 markers or 6 markers. They'll give you the harder questions. So let me start with the very basics.
There are two types of quantities, scalar quantities and vector quantities. If I'm describing something and I'm able to describe its magnitude that means the value, simple. If I weigh myself and it turns out to be 50 kg, so 50 kg is the magnitude, value of something. If you're measuring and you're getting some value, that is called magnitude. So scalar is that thing that tells you magnitude only. That means if a quantity is there and you can specify its magnitude only, that is called scalar quantity. Whereas the vector quantity is where you can describe its magnitude as well as you can describe its direction. Such quantities are called vector quantities. Say for example, I can say displacement. Suppose there is a point A and I want to go to point B. Obviously, I can take infinite number of paths in order to move from A to B. But the shortest one being A to B like a straight line, that is called my displacement. Here in displacement, I can say that I have displaced myself 10 meters and in which direction? It will be northeast direction. Here, I can easily specify my direction. And that's why the displacement, velocity, acceleration, all these quantities are called vector quantities where magnitude and direction both can be specified. Now coming to the mathematics, if I can specify direction, how in mathematics we specify direction? Using arrows. So I can use arrow that if I'm moving from A to B, I'll use this arrow. And if I'm moving from B to A, then I'll use this arrow. Since we have started vector, so we have to see how we represent a vector. Just like I told you, a vector is a quantity that specifies magnitude and direction. That means this straight line specifies the magnitude and this arrow specifies the direction. So if it's A to B, mathematically the notation is we write A to B and this represents the vector. That means the vector is moving from A to B. This particular thing is moving from A to B. Similarly, if it's B to A, it's coming back. The direction is in reverse order, B to A. But see, it's not like I'll do this one. That A to B and it's moving from B to A. This is a wrong notation. The arrow always points in a forward direction. So we have to write B to A. This arrow always in this direction, never reverse the direction of the arrow. Now this is specify the magnitude. A is the magnitude. Suppose B is the magnitude. This represents the magnitude and this arrow represents the vector. So I can say vector A to B is equals to A. That means it's moving from A to B and its value is small a. Now vector can also be represented by the column vector. Column vector is this in matrix form. We write it like this and we write x, y. Actually, vector is nothing, it's the coordinate in space. You are specifying how much is it moving. If I'm saying it's moving from A to B, so I can say that in order to move from A to B, it has moved, suppose 5 units in x direction and 2 units in y direction. This is how I can represent that in order to move from A to B. Only if I have to specify x and y direction. So to move from A to B, I have moved 5 units in x direction and 2 units in y direction. That I have to represent in column vector. X is, it has moved 5 units in positive direction and y 2. This is how you can represent a column vector. Next is, let me see the types of vector basically. First is equal vectors. If there are two different vectors having the same magnitude and same direction, then we can say that both are equal vectors. So to consider two different vectors, equal vectors, their magnitude and direction should be the same. So if it's A to B and its magnitude is A and C to D, its magnitude is A again, I can clearly see that they are both moving in same direction. You can clearly see as well as their value is also same. So ultimately I can say that both the vectors are equal vectors. Second is negative vector. Or the negative vectors are such kind of vectors that have the same magnitude but the direction are opposite. That's why they are known as negative vector. Suppose this is one vector a to b and this is another c to d. They both have same magnitude. A to b is also a and c to d is also a but in opposite direction. So I can say a to b vector a to b is equals to negative of vector c to d. Because in mathematics, to specify that they are moving in opposite direction, we use a negative sign. That's why even in physics, if you have studied the velocity, displacement, acceleration, we use the negative and the positive both. If I'm saying it's a negative 2 meter per second squared, it represents a deceleration, a negative acceleration. Similarly, suppose there is a vector AB. This is vector A to B. Its value is A. Now, if I have reversed the direction of it, first I'm writing that vector A to B is A in magnitude. But what I did, I have changed the direction. So vector B to A is still in A, but what has happened is that they have reversed the direction. So I can say that vector A to B is equals to negative B to A. Now this A will become negative A because you have reversed the direction. Next, which is the most important thing that you have to apply everywhere whenever you have to calculate vector in mathematics, it's vector law of addition. And we always use it in a triangle, which is also called triangle law of addition. It's A, B, and C. Definitely vector has magnitude, so I can say this is A, this is B, and this is C. Also, we know they have the direction. So arrows are like this, this, and this. We have to keep in mind that we have to add those two sides that move or that follow each other. Clearly, if I see the direction A to B and B to C, they are following each other. They're obviously moving in the same direction, whereas C is moving in opposite direction of them, clearly. That's why I have to add those two sides that are moving in same direction. So vector A to B plus vector B to C is equals to vector A to C. So A plus B is equals to C in this case. If in any question you have to calculate a vector, you first have to see that it's a part of which triangle. And then you have to apply this vector law of addition. They can never have the same direction. Then it will become a cyclic. That means suppose the direction is like this. Obviously, you can't apply the triangle law of addition if they are moving like this. Then you have to reverse the direction. Reversing the direction, that means suppose in this question it's given like this. Then what you will do, it's given as C to A is vector C. If you reverse the direction, A to C, this will become negative C. We just studied the negative vector. If we reverse the direction, the value become negative. So a vector A to C will become negative C. Now I can change the direction, vector A to C, but now this will become negative C. In that case, this will become vector A to B plus vector B to C is equals to vector A to C, and A plus B is equals to negative C. A simple parallelogram given. A, B, C, D. Vector A to B is given as A, vector B to C is given as B, and you have to calculate vector B to D. So first thing is, whatever you want to calculate, specify the direction. In a parallelogram, the opposite property of a parallelogram is what? The opposite sides are equal. Similarly, in vectors, in a parallelogram, the opposite sides are equal and have the same magnitude because they are equal vectors. So having the same magnitude and same direction. So A to B vector is A. That means I can clearly say that B to C is also A. If B to C is vector B, then vector A to D will also be D. Now it's very simple to calculate B to D. What we have to calculate? B to D. That means direction should be this. We have to see what they are asking. Accordingly, we have to use the direction. If I want to calculate vector, I first have to see triangle. For B to D, I can use either triangle 1 or I can use triangle 2. I can take triangle ABD to calculate the vector. Then, in order to apply the vector law of addition, I have to see which two sides are moving or following each other. So vector A to B and B to C clearly are moving in same direction, and vector A to D is moving in different direction. So in triangle ABD, vector A to B plus vector B to D is equals to vector A to D. I want to calculate vector B to D. So on transposing, vector A to D minus vector A to B. Vector A to D is B and vector A to B is A. So finally vector B to D is B minus A. This thing is when they have given some midpoint or something. A, B, C vector. Vector A to B is given as A, vector B to C is B, and vector A to C is C. Now there is a point M which is midpoint of A to B, and there is a point O which divides the line BC in ratio 1:2. O is the point that divides BC in ratio 1:2. That means BO ratio OC is given as 1:2 and M is the midpoint. Then the question is you have to calculate vector M to B, O to B. If they have given M is the midpoint, first thing is clearly I have to calculate A to B, which is already given. A to B is A. If M is the midpoint, that means vector A to M is equals to vector M to B. Or I can say that vector A to B is equals to twice of vector M to B, or simply vector M to B is half of vector A to B. Vector M to B is half of vector A to B. Vector A to B is A, so vector M to B is A by 2. Now, it's given as O is the point and it divides this into 1:2. That means O is dividing this in one part and this in two parts. I can use a whole long method to calculate what exactly B2 or O to B, but the best thing is what's direction given? B to C. So similarly, I can write B to O. I have to follow the same direction. B to C is given, so B to O should be in the same direction. So vector B to O is, it's one part over 1 plus 2. 1 plus 2 of whole big vector B to C. This is how we can convert a ratio into a proportion. So vector B to O is equals to 1/3 of vector B to C. Similarly, vector O to C will be, it's two part. Vector O to C is two part out of 1 plus 2 part of the larger vector B to C. So I can say vector O to C is 2/3 of vector BC. Since they are asking O to B, so I'll write B to C is given as B. So vector B to O is B/3, but they are asking O to B. So O to B is when I reverse the direction, the magnitude will become negative. Simple. So O to B will become negative B/3. That's your final answer.
So that's it for today. The remaining topic we'll do in the next class, and we'll do some questions from the worksheet that has already been uploaded on Akzsi app. Link in description box. So thank you and stay tuned.